Deriving complex numbers can be complex. The first thing, it's easy enough to divide a complex number by a real number. For example, if you have 10 minus 6i divided by 2, what you basically do is you split it into its real part and its imaginary part. So the real part is 10 over 2 minus, because of the minus sign here, the imaginary part, which is 6i over 2. And this can be simplified. 2 goes into 10 5 times, minus 2 goes into 3, or 2 goes into 6 3 times, 3i. And that's your answer. Okay? But it becomes complicated when you have to divide a complex number by a complex number, because that's not too easy. So for example, 2, to divide a complex number by a complex number. So say for example we have 4 minus 3i, and we want to divide it by 3 plus 2i. Well, we're not going to divide this complex number by this complex number straight away. The first thing we need to do is convert this into a real number. The main way to convert a complex number into a real number is to multiply it by its complex conjugate. So we want what's underneath the denominator, or what I just call on the bottom of the line, what's underneath the line, we want this to be real. So we have to make this part real. So to make a complex number real, you multiply it by its complex conjugate. Now, so we don't change the value. If we multiply here by 3 minus 2i, this is a complex conjugate of that. The real part's the same. The imaginary part has a different sign. This is plus, so this is minus. If we multiply or divide this number by this, we have to multiply it by 3 minus 2i. So we're really not changing the value, because 3 minus 2i divided by 3 minus 2i is actually 1. So all we're doing is it's just a trick to convert what's underneath into a real number. So that means now what we're going to do is the 4 minus 3i is going to be multiplied by the 3 minus 2i, and I'm putting it inside brackets because it's easier to keep track of it. And below the line, 3 plus 2i is multiplied by its complex conjugate, 3 minus 2i. Okay, so this is what we have to do. So the first thing I'll do is I'll sort out the bottom. Right, now it's called the denominator, but I'm just going to call it the bottom. Okay, so the bottom is 3 plus 2i multiplied by 3 minus 2i. And the quick way to do this is just to say that's equal to 3 squared plus 2 squared. 3 squared plus 2 squared. The real part squared plus the imaginary part squared. That's 9 plus 4, which is 13. So this is what goes on the bottom. Okay? Now the top is an actual multiplication. We'll have to do it out. So the top part is equal to 4 minus 3i multiplied by 3 minus 2i. You see, complex conjugate. Now this is not the complex conjugate of that. Okay? So this has to be worked out. So we split the brackets again. It's going to be 4 on the second bracket. 3 minus 2i, and then minus 3i on the second bracket. 3 minus 2i. So we multiply this out, and that will be 4 3s are 12. A plus by a minus is a minus. 4 2s are 8 times I. And then a minus by a plus is going to be a minus. 3 3s are 9 times I. And then a minus multiplied by a minus will give me a plus. 3 2s are 6, and an I times an I is I squared. Okay, so now we can tidy up this. We can sort out the minus 8i and the minus 9i. So that's 12. Now, here we're using the adding rules. Right, for integers, they both have the same signs, so we add them. Minus 8 and minus 9, so 8 and 9, 16, 17, I. And we keep the sign, minus 17i. And now when we're dropping the I squared, because we know that I squared equals minus 1, so basically it's 6 times minus 1, which will be minus 6. So we can say minus 6 here. Drop the I squared and change the sign. So now we have 12 is real and 6 is real. Well, minus 6, so 12 minus 6 will leave 6, minus 17i. And this is the top. So now our final answer, so the question was 4 minus 3i divided by 3 plus 2i is equal to 6 minus 17i, the top part, divided by the bottom part, 13, over 13. But you don't leave it like this. You split it into the real part, which is 6 over 13, and the imaginary part, which is minus 7 over 13i. Now that's the answer, and that's a standard method for doing that division. There's only one other division I'll show you. It's a bit of a trick, really. So say we have a question like this. Minus 4 plus 3i divided by 5i. Again, we do the same idea. We multiply above and below the line by the complex conjugate. And the complex conjugate of 5i is actually minus 5i. So we're going to multiply by minus 5i over minus 5i. Call this example 2. Well, 3. Example 3. Okay then. So now that's the same as minus 4 plus 3i in brackets times minus 5i divided by 5i times minus 5i. So if we do the bottom first, 5i times minus 5i, that's a plus by a minus will give us minus. 5 5s are 25, I times I is I squared. But I squared is minus 1, so that's minus 25 multiplied by minus 1. A minus by a minus is a plus. 25 times 1 is a plus. 25 times 1 is 25. So it's just 25. Could have just said 5 squared. Okay, then the top part. Minus 4 plus 3i times minus 5i. You could put the minus 5 in front here if you prefer that and work it that way, but it's all the same. So we're going to multiply the minus 4 by the minus 5i. So it's minus by minus is plus. 4 5s are 20 times I. Now we're going to multiply the 3i plus 3i by the minus 5i. So plus times a minus is minus. 3 5s are 15, and I times I is I squared. Now we can tidy this up a bit. The 20i will stay there, 20i, and then the I squared is minus 1, so I drop the I squared, which means I change the sign in front of the 15, and that will become plus 15. But I don't write the top like that. I write it with the real part first, so it's going to be 15 plus 20i. So now, the question was minus 4 plus 3i over 5i, and that's equal to the top here, 15 plus 20i divided by the bottom, 25. And again, we say 15 over 25 plus 20 over 25i. And if you want, you could reduce it. 5 goes into both of them fraction-wise. 3 over 5 plus 4 over 5i. That's done. Thank you.